Welcome to JB class. My dear students, today we are going to have these questions, question number 7 and 8. Question number 7 here says, write the fractions. Are all these fractions equivalent? In question number 7, we have to find the required fraction of the shaded portion of each and every figure. So now, first of all, we have to know about fractions. We have got so many types of fractions. In the previous class, we learned about a type of fraction that is about equivalent fractions. Then, what are equivalent fractions? Equivalent fractions are those fractions having the same values. One second. Equivalent fractions are those fractions having the same values. So, now let us check it out whether these fractions given in the question as figures are having the same values or not. We have to find the fraction of the shaded portion. Okay, in these figures 1, 2, 3, 4, we have got the shaded portion and unshaded portions. So now we have to find the required fraction of the shaded portion. Okay, now let us have A. In question number A, we have here one circle. Okay, in this circle we have got two halves. One half is shaded, completely shaded. Another half is unshaded. So since here in this circle we have got two halves, so the total part or whole part is 2. In the fraction we have got two parts. We just discussed about it in the previous classes. Okay, first one is the total part or whole part, and the second part is the part. Okay, the part may be smaller or greater according to the question. So now let us have here the circle is divided into two halves, that means 1, 2. So the total part or whole part should be 2, that means the denominator should be 2. Okay, and the shaded portion, we are going to find the shaded portion here, or there is only one shaded portion, so the numerator should be 1. That means the required fraction of this figure is 1/2. Okay, now let us go to the next, that is B. In question number B, the whole circle is divided into 4 equal parts, 1, 2, 3, 4. Okay, so the denominator should be 4. And how many shaded portions are there? We have to count. How many are there? 1, 2. Only 2 are there. So 2. That means the required fraction is 2/4. So now we have to convert this into its simplest form. Okay, we learn about the simplest form of a fraction. Okay, in the previous class. So let us convert. So we can go it by 2. 2 1s are 2. 2 2s are 4. So the required answer is the value is 1/2. Likewise, we can find in question number C, let us see, the whole portion is divided into 1, 2, 3, 4, 5, 6 equal parts. So the denominator should be 6, and the shaded portions are 1, 2, 3. There are 3 shaded portions. So we can just convert it into its simplest form, that is 3 1s are 3, 3 2s are 6. That means 1/2. Likewise, let us have this question number D. In question number D, the whole circle is divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So the denominator should be, or the whole part should be 8. And then how many shaded portions are there? 1, 2, 3, 4. 4 are there. Okay, there are 4 select portions are there. So now let us convert into its simplest form, that is 4 ones are 4, 4 twos are 8. So the answer is, the value of the fraction is 1/2. First of all, we have to check it out. These values are equal or not. The values of the fractions are equal or not. That means if they are equal, we have to say that the fractions are equivalent. If not, they are not equivalent. So let us check it out. The values are equal or not. For the first question number A, the value is 1/2, B also 1/2, C also 1/2, and D also 1/2. That means each and every fraction has the value 1/2. That means they have got the same values. That's why these fractions are said to be equivalent. Okay. So now in the question, are all these fractions equivalent? So we have to say yes, yes, yes. All these fractions are equivalent. So this is the question number 7. Okay. In question number 7, we did, first of all, we found out the required fractions. Okay, the required fractions we found out. After that, we check it out whether they have got the same values or not. So in the answer, we got all the fractions have got the same values. That's why they are equivalent, because equivalent fractions are those fractions having the same values, isn't it? That's why, since they have got the same values, they are all equivalent. So now let us move to the next question number 8. In question number 8, the question says, find the equivalent fractions of 3/5 having denominator 20 and numerator 27. In this question, we have to write another equivalent fractions whose denominator is 20 and the numerator is also 27. That means first of all, we have to write another equivalent fraction whose denominator is 20, and the second question number B, we have to write another equivalent fraction whose numerator is 27. Okay, so here also we have got two questions. Now let us have A. In A, denominator 20. So first of all, we have to write the given fraction 3/5. Write the same fraction, and we have to convert or make this denominator into 20. That is in the question. Okay, that is in the question. That's why we have to convert this denominator into 20. Okay, we have to convert into 20. So now, to convert this denominator into 20, we have to multiply a by number. Okay, by a multiplier. That means we have to multiply it by 4, because 4 5 is 20. Okay, since I multiplied in the denominator, again I have to multiply to the denominator by the same number, that is by 4. That is 4 3 is 12, 4 5 is 20. So this is the another equivalent fraction of 3/5. Okay, like this we can have B. In question number B, that is numerator 27. Numerator 27. In this question also, we have to write the same fraction 3/5. Then to write the same value 3/5. Now we have to convert this numerator 3 into 27. Okay, that's why we have to multiply by a number, and that number should be 9, isn't it? Because 9 3 is 27. So multiply by 9 to both the numbers 3 and 5. That means we have to multiply in numerator by 9. Also we have to multiply in denominator by 9. Okay, that means we have got 9 3 is 27, 9 5 is 45, like this. Okay, That means to get the desired number, we have to multiply by a number. Okay, that number is called multiplier. That means we have to multiply by a multiplier to get the desired number, whether it may be the denominator or it may be the numerator. Okay, according to that condition, according to the conditions of the questions, so we have to multiply to both the numerator and denominator. Okay, so here in this question number 8, we have got two questions. First one, we have to convert this fraction 3 by 5 to another fraction whose denominator is 20. So we have multiplied in the denominator by 4 to get the denominator 20. So we have got 4 3s are 12, 4 5s are 20. In the same case, we have to repeat here in question number B. Numerator is 27. So in the numerator, we have to make this number 3 into 27. So we have to multiply by 9. Isn't it? 9 3s are 27. So in the denominator also we have to multiply by the same number, that is by 9. That is 9 5s are 45, like this. Okay. So today we have got two questions, question 7 and 8. In question number 7, we just found out the required fraction from each and every figure, and from there we check it out whether they have got the same values or not. If they have got the same values, and then they are all equivalent fractions. So we got it from question number 17. Question number 8 2, we did the same thing, that is about equivalent fractions. Okay, we write another equivalent fractions and then we convert into to the desired numbers of the denominator and the numerators as well. Okay, for today let us have only these two questions. Okay, in the next class let us have more about fractions. Okay, thank you, have a nice day.